All right, hopefully you grabbed a snack before your second video of the day. This is what happens, what we'll call the rules, if you were to take your data set and change your data values by the exact same amount. So you can't just change one or two of them every single piece of data. So again, if you have a data set and then for some odd reason, and it might actually be an odd reason, you actually have to adjust every single piece of data, it does change your statistics or your numerical summaries. And we're going to look at that by adding and subtracting a constant to every piece of data. And then we're also going to look at multiplying and dividing a constant to every piece of data. So this has been requested that I finally give you results on your data of when I asked you how old you thought I was. And this is both of my classes' responses. I have noticed I've highlighted down here this piece of data right here. So this is part of data collection. I got 149. Clearly that's impossible. So I don't know if somebody put that in there to be funny, because it is pretty funny, or if somebody meant to type 49 and they accidentally put a 1 in front. So as a person having to analyze this data, I have to make a decision about this. If I leave it in, it's going to impact my mean, my standard deviation, and the graph of my distribution immensely. It will have very low impact on the median or the interquartile range, because the median will still be fairly close to where it would be if this value were in it or not. But so as the data analyzer, I'm going to throw this piece of data out and not count it at all. So this is actually the data I will use. And again, I put this in my calculator, and you could put it in either as individual pieces of data, or you could put it in a frequency table, and that might want to do that because I noticed that 36 gets repeated a few times, 38 quite a few times, 40 a whole bunch of times, 41, 42. There's a lot of repetition in the data value, so you could put it in as a frequency table. Either everything goes in list 1, all the pieces of data, or in list 1 I could put 33, 34, 35, 36, 37, 38, 39, and then in list 2 tally up how many there were. So there's 1 of 33, 1 of 34, 1 of 35, 3 of 36, 2 of 37, etc. So I did that, and I created a histogram of the data. I did this with, again, with the spreadsheets instead of my calculator. We'll do some with the calculator in a minute also. But this would be the histogram of your guesses for my age, and I think we're going to talk about what we consider the shape of that. These are the numerical summaries that came out with it. Again, I did put it into my calculator, and I ran these just using 1var stats. I did in a frequency table, but again, the mean is 41.7, standard deviation is 4.9, the median is 41, and then the range is either 24, or you could do the IQR, which looks like 6. So the first thing we're going to do is answer what the shape is, and that is it is skewed to the right. There is a bulk of data here between 35 and 45, and then there's one person who for some reason thought I looked excessively old and put me down as 57. So that pulled the data to the right. Because of that, we should use the median and the IQR to talk about our measures of center and spread, because when you're skewed, you want to use those. And so there's the median and there's this IQR. I did write down the mean and the standard deviation because we're going to want to look at what happens to all of these measures as we add a constant to our data. So over here, after you find some particular information about me, maybe that I have an extensive collection of Vans shoes, and you're like, well, there's no way that a 52-year-old, I thought there's a 57, oh no, never mind, yeah, a 57-year-old could have a pair of Vans shoes. That's just not possible. So everybody's like, you're right, we're all off. We have to subtract 5 from every single one of our guesses. So this is the same data set, but I subtracted 5 from every piece of data. So this was a 57, now it's a 52. And so that's where these data values are coming from. And so we are going to, this is adjusted. Again, so I'm subtracting the same amount from every piece of data. Every single piece of data got subtracted by 5. And I'm going to show you, excuse me, how you can do that in your calculator very quickly. So if I go to Stat Edit, and I just want to show you that I have over here in my calculator, I did mine as a frequency table because I didn't want to type all these pieces of data in, but it probably was probably more typing to put it in a frequency table. But if I want to subtract 5 from every single one of these data values and I don't want to actually manually do it, I can come over here to the top of list 3, just like we would go to clear it, and I can say, all right, I want to pull up list 1, which is second 1, and that's going to now take every piece of value in this column, and I want to subtract 5 from it. So this is the formula I'm telling to do in this entire column, and it will do it for every piece of data. So there we go, boom. So now my value list is list 3 and my frequency is still list 2, so that's a little bit backwards. But that's one way to change every piece of data in your data list without having to actually go through and change every single piece of data. You put a little formula in the top. All right, so once I subtract 5, here is the histogram. Again, I do want to point out, notice that the shape of this did not change at all. It is still skewed right. In fact, if I come over here, it almost looks identical to the original one. Like literally almost no change at all. So adding or subtracting a constant does not change the shape of your distribution. So I ran my one variable stats, and I have a new mean and a new standard deviation. I also have a new median and new quartiles, so I have to calculate all of those new values. So my new interquartile range is 6, again 39 minus 33. The median is 36 right there. Mean is 36.7, and my standard deviation is 4.93. So this is all the data after I took 5 from every piece of your guesses for my age. And now we're going to compare them. So this was the original data up here. This is after I subtracted 5. Notice that the mean went from 41.7 to 36.7. That is a difference of 5. The standard deviation went from 4.93 to 4.93. That's exactly the same. The median went from 41 to 36. That is minus 5. Notice that all measures of position, including the quartiles, all changed by 5. The quartile 3 down by 5. The max down by 5. But if I calculate the IQR, which is 39 minus 33, and I calculate this IQR, 44 minus 36, they are 6 in both cases. Just like this guy down here, the standard deviation didn't change. So this is a very big and important piece of information. Shape doesn't change. Spread doesn't change when you add or subtract by a constant. What does change? All the specific measures of center and position. All right, moving on. This is just a summary of it. When you add or subtract by a constant, it will change measures of center and position. That's it. It will not change the shape, and it will not change the spread. Any measure of spread will stay the same. Now we're going to move on to the second thing that can happen, and that would be multiplying or dividing by a constant. So here are the estimates that you made of my weight. And again, here's an interesting piece of data. 5'8" is close to my height. I'm 5'9", but I'm not 5'8" in weight. So this piece of data, again, as the person who's measuring data, I would just not count that, and I would have all of this data right here. So I do want you to do this. Well, actually, I think I'll have you do the switch over. No, I do want you to put this in your calculator, so pause it and put all this in your calculator. All right, now we're going to do a histogram and run one variable stats. So if it's in your calculator, those should be things that you can do very quickly. So here is my histogram of your weights and my one variable stats. Now, if your histogram doesn't look exactly like mine, that's because I went into the window and I changed my values from my min and how high I went up here, and I made my interval 10 for my x's so that I just have this nice clean 150 to 160 to 170 to 180, 190, etc. If yours looks a little bit different because you didn't do that, do not worry. It doesn't matter. It's still a perfect histogram for this data set. There is the mean is 156, so on average you thought I weighed about 156 with a standard deviation of 17. Median weight is 150, and again there was a couple over here on the far extreme that are pulling this data, so we could discuss it in terms of its shape, which is skewed right again. The median therefore would be what I would use, and the IQR would be the difference between these, which is 19 pounds. I also wrote down the mean and the standard deviation because we want to see what happens to all of these measures when we do something to it. So what happens with this data is you've discovered that during this strange pandemic time, I've been eating bags of potato chips and loaves of homemade bread every day. And so you're like, oh, well, that's what we thought he weighed before. Now we're pretty sure he has doubled down on his weight. So you're going to double your guesses on my weight, which means you're going to multiply by 2. So take a second, go in, try in your calculator to change your list of weights by doubling them using that little trick I showed you earlier, and then do a histogram and run one variable stats. Pause. Unpaused. Perfect. Here we go. Again, this is the actual data. I manually doubled all of them in here, but that doesn't matter because hopefully you did it in your calculator and you took care of it. So the histogram is covered up a little bit on mine. Again, I changed my boundaries a little bit, but I doubled it, so now I made my bin widths about 20. But notice that it is still skewed to the right. It did not change the shape. If I zip back over here to this one, there's the first graph. I come over here, there's the second graph. I do have a new mean. There's my standard deviation, my median. Those all went up because they're all individual values over here. And we're going to actually write them down. Again, it's skewed right, so I should use the median and the IQR, which is the difference of those, which is now 38 pounds. And I have a new mean, which is 312, and a new standard deviation of 34.26. So can you tell what happened to all of the data, all of the statistics? And you may have to zip back to what they were a minute ago, but maybe you remembered some of them. But if not, I'm going to compare them. So here we are. This is our first data, and my mean was 156. New data, mean is 312. What happened to those two numbers? The first standard deviation was 17.13. The new standard deviation is 34.26. What happened to that number? That changed. That's different from when we added. The median was 150. Now it's 300. That's a pretty easy one to tell what happened. The IQR was, I believe, if I quickly look at this, 19. And now, a second ago, we said this is 38. So I went from 19 to 38. What happened? So what we should notice is the shape stayed the same. It's skewed to the right. It did not change. It's a little more spread out because I'm now going up to 320, which is a little bit farther than I was, on this particular band going up to 160, but it looks the same. The center, the median, doubled. The spread, the IQR, doubled. The mean, doubled. The standard deviation, doubled. They all doubled. So this is a little bit of a difference. When you multiply or divide by a constant, all of your measures change by that same value. So if I divided everything by 5, all of my statistics would be divided by 5. Not the variance, but we can talk about that some other time if we have to. And the other thing to keep in mind is the shape doesn't change. So you might want to jot this down. This is like a linear transformation, applying a multiplier and adding something. And this is just telling you that the mean and the median, the mode, they're all going to be transformed by both of those things when you add a constant and multiply. And this could be subtract. If we do that with standard deviation, however, standard deviation is not going to be impacted by the adding. So this would be what all I would have to do to change my standard deviation. It would be a multiplier. So if I had to do, if I was given the variance, I have to square that multiplier and apply it to the variance. Again, no adding or subtracting. So this you might want to kind of look at, but this is telling you that the mean and all measures of center and position change by both things in a linear transformation, and for the spread, the only thing that is impacted is the multiplier. So just quickly, I ran the mean and standard deviation of the number of states you visited, and it was 13.8 and 6.1. And if after this crazy shutdown you all go crazy and go, we got to go visit more states, and you visit 3 times as many states as you had, plus an additional 4, I know, is that even possible? I don't know. What happens is the linear transformation is 3x plus 4 because I'm multiplying my data by 3 and adding 4. And if I do that to the mean, it would be 3 times whatever the mean was plus 4. And that would get me a new mean of 45.4. So I put both of those linear pieces together. If I was doing it with the standard deviation, the old standard deviation was 6.1. So I would put this in here like this. And then, no, there's no adding when you change your standard deviation, just the multiplier. So it becomes 18.3 states. So notice, no adding when you have a linear transformation on spread. And that is it, just in time. Hope you enjoyed.